Welcome back to the deep dive. Today, we are really diving into something big. We're looking at probably the fastest acceleration cycle humans have ever seen.
Yeah, it feels like it. Our source material today comes from some heavy hitters, Sam Altman and Vinod Khosla, talking very frankly about the future, specifically AI.
And we're not just talking next year. They're painting a picture stretching out, decades, 2035, even 2050.
Exactly. So our mission for you today is to break down their insights. What's the velocity look like, say, in the next 18 months? And then what are the really big long-term shifts for the economy, for jobs, for how we value things?
Okay, let's start with that long view then, 2035 to 2050. I mean, it's almost impossible to really picture, isn't it? The tech changes so fast already.
Right. And Altman made that point. He said, look, basic human stuff, biology, needing connection, eating lunch, that probably won't change much. But the rate of technological change, he thinks it's going to be, impossible to frame using any model from the last 50 years, just off the charts.
And Khosla ties that speed directly to, well, pretty dramatic economic consequences.
He does. He predicts that the 2030s will see a faster demise of the Fortune 500 than ever before. Think about that. Faster than the Industrial Revolution, faster than the internet boom.
Wow. Okay, but hang on. We hear this a lot, right? New tech comes along, it'll kill the incumbents. The internet was supposed to do that.
Yeah.
And okay, things shifted massively, but a lot of big companies adapted. They bought startups or, faded slowly. Why is AI supposedly different this time? Is it just market share loss or like total failure?
The sources suggest it's more like genuine failure, adaptation failure, because the speed is just too much.
So they just can't pivot fast enough internally.
That seems to be the core idea. It's the classic incumbent problem, but on steroids, especially in software. That's where it hits first and fastest.
How so?
Well, think about it. We're moving towards software being like just-in-time written. An AI chatbot just writes it for you on the spot.
So you don't need to subscribe to a SaaS product for some function.
Exactly. You just tell the AI what you need and bam, it generates it.
Hmm.
That completely upends the, $500 billion SaaS market?
That's a huge wave. But okay, what about the physical world? Supply chains, factories, building actual stuff. That has real world friction.
Absolutely, yeah.
Huh.
The physical world always takes longer. You can't just instantly conjure up a new chip factory or something.
Right.
But the consensus in the material seems to be that 2040 is, and this is the quote, long enough for really big disruption even there. In the complex physical sectors.
Okay, so digital gets hit immediately, but the
Yeah.
physical stuff, the clock is ticking just a bit slower.
Pretty much. Which brings us to maybe the biggest question for everyone listening.
Yeah.
Jobs.
Yeah, the estimates here are, well, they're kind of mind-blowing. AI handling at least 80% of intellectual jobs by 2035 or so.
And it's not just theory. They point to roles where AI development is happening right now, today.
Like what?
AI versions of doctors, therapists, even oncologists, chip designers, software engineers, sure, but also high-level salespeople, accountants.
So it's not just repetitive tasks, it's core knowledge work.
Exactly. The stuff we thought was safe,
Okay, so the big question then. If AI can do 80% of that work, potentially better, does that mean 80% intellectual unemployment?
Yeah.
Or is there something else going on, something human?
This is where it gets really interesting, synthesizing the different viewpoints. There's a strong counter-argument based on what Altman calls deep biological things. Meaning, even if an AI is technically better at, say, diagnosing an illness, people might still strongly prefer a human doctor. It gets down to this idea of caring about other people.
Connection, empathy, that feeling someone actually cares.
Precisely. Altman used a great example. A mediocre human teacher might actually motivate a student more than a great AI teacher.
Why? Because the human is real. They've invested time in you personally.
Exactly. That sense of connection, that shared humanity.
Yeah.
It's a fundamental drive. You can't easily code that.
No matter how good the language model gets.
And the sources stress our basic biological programming. It's not going to evolve in 15 years. People will still want status. They'll compete. They'll absolutely prioritize caring for their kids, their parents, their families.
So AI might free up time from work.
Right. Maybe you don't need that 60-hour week just to pay the bills anymore. That time could go towards those relationships, those connections. But the need for those things, the value we place on them, that stays. We're wired for real connection, real status games.
That distinction of what AI can do versus what we want a human for seems absolutely critical for navigating what's coming.
It's a whole ballgame, really.
Okay, let's zoom in then. Talk about the immediate velocity. Because the acceleration predicted just between now and the end of 2026. It sounds insane.
It does. We really need to focus on these next 18 months. So think of ChatGPT launching. That was the 0 to 1 moment, right? The big psychological shock.
Yeah, everyone suddenly got it?
Since then, we've maybe moved from, say, 1 to 10 in overall capability, proving the concept, refining it.
Okay, so what's the forecast for the next leap? From now to the end of 2026.
The forecast is 10 to 100.
10 to 100 in capability. That's an order of magnitude jump.
In less than 2 years. Now, the sources do say this 10x leap might not feel as wild psychologically as that first launch.
Why not?
Because now everyone kind of expects AI to be amazing, AGI is anticipated, the shock value is lower maybe, but the actual real-world impact, much, much greater.
Can you make that 10 to 100 feel more real? Like for someone working in engineering or research?
Okay, imagine you're designing a chip today. The current AI, the 10 version, maybe it helps generate 50% of the code, suggests some optimizations.
Right.
But you, the human, still spend, I don't know, 2 months validating it, tweaking it.
Right, that final optimization loop.
Now imagine the 100 version. The AI does that entire 2-month optimization loop in seconds. It just handles it.
Yeah.
Your job then shifts, right? You're not doing the iteration. You're setting the high-level goals, verifying the final output. That's the kind of leverage shift we're talking about.
Wow. Okay, so what's driving this? This relentless exponential acceleration feels like a crazy feedback loop.
It is. And it comes down to basically 3 core scaling laws working together. First, just better algorithms.
Smarter ways of doing things?
Yeah, finding steeper scaling laws, getting more bang for your buck, computationally speaking, things like reasoning, and especially unsupervised learning. That's huge.
Why is unsupervised learning so important?
Because it means the models can learn from data without humans having to manually label everything first. That removes a massive bottleneck: time, labor, cost.
Okay, so better algorithms. What are the other two?
Second, simply bigger computers. More powerful chips, obviously, but also critically, getting better at connecting huge numbers of them together efficiently.
Got it. And third?
More data.
Well,
And crucially, better data. It's not just about quantity. Quality and diversity of data are key.
and then there's the AI actually helping build the next AI, that messy joint acceleration idea.
Exactly. We're already seeing it. Systems like Codec, mentioned in the sources, start by assisting researchers. Maybe it generates 10% of their output initially. But as the AI gets better, it moves towards enabling, like 10x human output. Whether you call that AI helping the human or the AI basically doing the research, the result is the same. Faster progress.
Yeah.
Every single year. Accelerating the discovery of those better algorithms we talked about.
This has massive implications for anyone investing money or trying to build a company right now. If the foundation is shifting that fast under your feet, how do you even operate? Where's the opportunity?
The advice from the sources here is really clear, almost sharp. It's don't waste your time trying to build or invest in another AI research lab.
Don't chase the last winners.
Right. That race needs incredible amounts of computing power, specialized talent. It's pretty much consolidated already. The focus, they argue, needs to be 100% on the thing that comes next. The application's built because AGI exists.
The classic transistor analogy.
Exactly. The transistor itself was revolutionary, huge value. But the real long-term market value wasn't just in the transistor company. It was in everything. It enabled radios, TVs, computers, the whole ecosystem.
So the next giants won't be another OpenAI necessarily?
Probably not. It'll be the companies, maybe whole industries, that are completely transformed by OpenAI and systems like it.
It's interesting how they learned what the product actually was with ChatGPT. There's a story there.
Yeah, that was a huge learning. When GPT-3 first came out via API, everyone thought the killer apps would be utilities. You know, copywriting tools, summarizers, that sort of thing.
Makes sense.
But the thing that really took off, the sleeper hit, was the playground. Just the basic interface where people could chat with it all day long.
Just talk to it.
Yeah. It showed this deep, maybe psychological need people had, not just the business function need. They wanted to interact, to converse. That was the surprise.
And that led to a really key insight about how to judge new products in this fast-moving space, about retention.
Absolutely critical insight, which is if your product has any retention at all, like even 5% of users sticking around and their usage actually increases over time, you might be onto something really big.
Even just 5%, that sounds low.
Well, the default for most new software, historically, is a straight line to zero usage after the initial hype dies down. So in this AI world, if anything shows stickiness, even a little bit, it suggests you've tapped into a real persistent human need or utility. It's a very different benchmark.
Okay, looking really short term then. Where's the immediate disruption, the immediate revenue happening in enterprises, say, for the rest of this year?
The sources were super specific on this.
Mm.
The AI software engineer.
The AI coding assistant, essentially.
And more. Actually acting as an engineer in some capacities, they see this as the single most disruptive thing to enterprises right now. Think about it. Engineering time is often the biggest bottleneck for companies building digital stuff.
Right, slows everything down.
If AI can massively boost the output of every engineer, or even take on some of that work directly, that constraint just dissolves. It unlocks huge value very quickly.
And anything else alongside that?
Yeah, they also mentioned virtual coworkers, especially in customer support and sales. Those are already showing clear, measurable ROI for businesses.
Okay, let's pull back again. Look at the big societal picture. If AI makes labor cheap, makes goods cheap, we're talking massive deflation, aren't we?
That's the prediction. A hugely deflationary economy in the 2030s. But different from past deflation, because it could hit almost all essential goods and services at once.
Like what?
Cost of basic food, clean water, healthcare, education, all potentially approaching zero or near zero because of extreme AI-driven efficiency.
Okay, but if essentials are basically free, where does value go? Where does wealth accumulate? People still compete, right?
That's the fascinating part. If utility becomes abundant, the theory goes, human competition shifts entirely to things that are inherently scarce or about status. Like the sources joked, but maybe seriously, about bidding up Da Vinci paintings to $1 trillion, or unique real estate, or, naming rights to galaxies, who knows? Silly status games, essentially. We solve resource scarcity, but the competition for status just moves elsewhere.
That is a wild thought. $1 trillion painting next to free healthcare. What about global access, though? Won't this just concentrate power and wealth even more?
Well, the counter is that tech tends to spread. Look at ChatGPT, already one of the biggest websites globally. It's providing free or very low-cost access to powerful AI for billions.
So it democratizes access to things like medical advice or education.
That's the potential, yes. It could be a massive benefit for the world, leveling the playing field in many ways.
But there's still the issue of who controls the underlying compute power, right? That's a governance challenge.
A huge one. The sources highlight 3 key areas governments must tackle. 1, setting global rules and safety guardrails. 2, figuring out distribution, how the economic benefits of this abundance are shared. And 3, dealing with complex data issues, privacy, sovereignty.
And how do you solve the concentration of compute power itself?
Interestingly, the argument wasn't necessarily about regulating the rich to slow them down. It was more about radically increasing the supply, making way more compute, so it stops being a scarce commodity controlled by a few and becomes abundant, accessible to everyone.
So it all comes back to that velocity again. Driven by scaling, but hitting up against our fundamental human needs and desires. That tension seems key.
You have to hold both ideas at once, I think. The tech velocity is almost a given at this point, but how we humans react to it, what we choose to value, where we seek connection, that's the real unknown. That gap between what AI can do and what we'll still want a human for, that's where the future of work and maybe meaning lies.
Right. Well, let's leave you with one final thought, something that came up in the source material about just managing all this change. Running these organizations like OpenAI that are scaling at this incredible pace, it's apparently extremely hard.
Yeah, Altman mentioned feeling constantly oversubscribed, just too many critical decisions needing to be made too fast, often without enough information.
And he said there's basically no existing playbook, no Silicon Valley wisdom for how to manage that kind of intense, high-stakes acceleration within an organization. So here's the thought. If this AI revolution spins up thousands of new ventures, all scaling incredibly fast, all facing complex, critical decisions daily, what new kinds of organizational structures, what new management wisdom will entrepreneurs need to invent just to cope with the sheer volume and speed of decision-making required? Something to think about as we all try to keep up with this curve.